Let us begin by leaving the noise of our world behind. Close your eyes and imagine the profound quiet of space. Picture the planet Mars, a rusty jewel hanging in the black velvet of the cosmos. Its surface is bathed in an eerie silence, broken only by the whisper of a thin wind. Tonight, we contemplate a celestial story of a visitor from between the stars. This is a tale not of loud explosions, but of subtle, cosmic transformations. We will explore the science of a close encounter, a dance of gravity and chance. As we journey through the mysteries of our solar system, let your mind and wind allow the vast, peaceful scale of the universe to lull you into a state of deep relaxation. Listen to the rhythm of the narrative, as steady as the orbits of the planets. Breathe slowly, and let the infinite cosmos carry your thoughts away. We begin our voyage to the red planet, and to the edges of scientific understanding. Rest now, and let the story unfold. The story begins not with a bang, but with a faint dot of light in a telescope's eyepiece. On a clear night, an automated sky survey detected an object moving against the backdrop of fixed stars. Its trajectory was immediately calculated and found to be profoundly unusual. Unlike the countless asteroids and comets bound to our sun by gravity, this one was a visitor. It was following an open, hyperbolic orbit, a path that could only mean it originated from beyond our solar system. This officially designated it as an interstellar object, the first such confirmed visitor of its size. It was given the name 3I Atlas, a label denoting its unique status and discovery order. Initial estimates placed its size at approximately 200 meters in length. This is comparable to a large city block, a substantial mass for an interstellar traveler. The first anomaly appeared when astronomers measured its brightness. Most comets brighten steadily as they approach the sun and their ices begin to vaporize. 3I Atlas, however, exhibited sudden and unpredictable flares in luminosity. These outbursts would appear without warning and fade just as mysteriously. They were violent and chaotic, suggesting internal instability rather than gradual heating. Spectroscopy analysis revealed a second and more profound mystery. The light reflected from 3I Atlas contained chemical signatures that did not match any known comet or asteroid in our solar system. The ratios of isotopes, the fundamental varieties of elements, were alien. They indicated formation environments around a different type of star, under conditions we have never directly observed. This object was not just a rock, it was a museum piece from another stellar system. Perhaps the most unsettling characteristic was its rotation. Natural asteroids and comets typically tumble through space in a chaotic spin. Their rotations are affected by millions of years of collisions and outgassing. 3I Atlas, in contrast, maintained an eerily stable and regular rotation pattern. The periodic changes in its brightness followed such a precise cycle that it seemed almost controlled. This regularity quietly prompted some researchers to question the nature of the processes at work. Was this a natural phenomenon operating by rules we did not yet understand? Or were we witnessing something that challenged our very definitions of natural and artificial? These initial anomalies made 3I Atlas an object of intense scientific fascination and quiet concern. It was a puzzle box from the galactic void, and it was on a path that would bring it uncomfortably close to our cosmic neighbor. The laws of orbital mechanics are both beautiful and unforgiving. Once the trajectory of 3I Atlas was calculated, its future path could be predicted with immense precision. The equations of Newton and Einstein pointed to a specific date and time, October 3rd, 2025. On that day, the interstellar visitor would make its closest approach to the planet Mars. The predicted distance of closest approach was approximately 30 million kilometers. In the vast emptiness of interplanetary space, this qualifies as a very close pass. To provide perspective, this is only about 70-5 times the distance from the Earth to its moon. It is a proximity that falls well within the gravitational sphere of influence of the red planet. Mars, our next frontier for human exploration, is a fundamentally vulnerable world. Its atmosphere is tragically thin, possessing less than 1% of the pressure of Earth's air. This tenuous blanket of carbon dioxide provides negligible protection against incoming objects. On Earth, our thick atmosphere acts as a shield, burning up smaller meteors and slowing larger ones. Mars might as well be naked to the vacuum of space, offering no such sacrificial barrier. Furthermore, Mars lacks a global magnetic field like the one that protects our planet. Billions of years ago, its planetary dynamo shut down, and its magnetic field collapsed. All that remains today are patchy, fossilized magnetic fields locked in its ancient crust. This means the surface and atmosphere of Mars are directly exposed to the solar wind and cosmic radiation. Any electromagnetic effects from a passing comet would meet little resistance. Compounding the situation was the celestial timing of this event. The encounter was scheduled to occur during a period known as solar conjunction. This is when Mars, the Sun, and Earth align, with the Sun positioned directly between the two planets. The Sun's enormous radio output creates severe interference for communications. For several weeks around the encounter, our ability to talk to our assets at Mars would be dramatically reduced. We would be flying blind during the most critical moments of this cosmic flyby. In orbit around Mars, a fleet of robotic sentinels represents humanity's investment in the planet. The Mars Reconnaissance Orbiter, with its high-resolution camera, has mapped the planet in stunning detail. The MAVN spacecraft studies the thin Martian atmosphere and its interaction with the solar wind. ESA's Trace Gas Orbiter and Mars Express add to this network of eyes and ears. On the surface, the Perseverance and Curiosity rovers continue their slow, methodical exploration. These billion-dollar machines were designed for the known, stable environment of Mars. They were not built to withstand a cosmic event that could fundamentally alter that environment. The stage was set for a high-stakes encounter between a known, fragile world and an unknown, unpredictable visitor. When discussing cosmic threats, the most immediate and visceral danger is that of a direct impact. The mathematics of such an event are as elegant as they are terrifying. The kinetic energy carried by a moving object is proportional to its mass and the square of its velocity. 3I Atlas was not only substantial in mass, it was traveling at interstellar speeds. These velocities, measured in dozens of kilometers per second, far exceed those of typical solar system asteroid. The initial calculated probability of a direct impact between 3I Atlas and Mars was astronomically low. The odds hovered around 1 in several million, a statistical near-minus impossibility. But cosmic roulette has a way of defying the odds in unexpected and dramatic fashion. The true concern for planetary defense specialists was not the main nucleus of 3I Atlas. The nightmare scenario was the possibility of fragmentation. Comets are often described as dirty snowballs, fragile mixtures of ice, rock, and dust. If 3I Atlas were to suffer a structural failure, it could break apart violently. This process is not a gentle cracking, but an explosive decompression. Trapped volatile gases and ices under pressure would suddenly find escape routes. The comet's nucleus could disintegrate into a cloud of fragments, each a projectile in its own right. Imagine a shotgun blast replacing a single bullet, scattering danger across a wide area. Now, picture this fragmentation event occurring within the gravitational reach of Mars. The main body might continue on its harmless trajectory, passing by the planet. But the newly liberated fragments would each follow their own chaotic paths governed by momentum and gravity. Some pieces would be deflected onto new trajectories that could intersect with Mars itself. A fragment just 100 meters across, a mere piece of the whole, would be catastrophic. Traveling at its immense velocity, it would carry kinetic energy equivalent to thousands of nuclear weapons. Unlike a bomb, which releases energy gradually, an impact delivers all its energy instantaneously to one point. The immediate effect would be the creation of a crater spanning 15 to 20 kilometers. The event would excavate millions of tons of Martian rock and soil, hurling it high into the sky. Much of this ejecta would be launched on suborbital trajectories, raining down across the planet. The surface would be pummeled by secondary impacts for hours, or even days after the initial collision. The atmospheric effects would be equally dramatic and long-lasting. The fine dust injected into the atmosphere would trigger a planet-wide dust storm of unprecedented scale. Sunlight would be blocked, causing surface temperatures to plummet in a Martian version of a nuclear winter. This climatic chaos could persist for years, fundamentally altering the planet's environment. The delicate systems of our rovers, reliant on solar power and stable conditions, would face an insurmountable challenge. The dream of exploring Mars could be set back decades by a single, well-placed fragment from a shattered visitor. Forget everything you think you know about cosmic impacts. The most insidious attack 3I Atlas could launch might not involve a single piece of debris striking Mars. Instead, we must consider an invisible assault on the planet's electromagnetic environment. Mars stands uniquely defenseless against this type of threat. Our Earth is wrapped in a protective magnetic cocoon called the magnetosphere. This dynamic shield deflects the charged particles of the solar wind, funneling them harmlessly toward the poles. Mars, with its dead magnetic field, has no such global protection. What remains are scattered, localized magnetic umbrellas frozen in the ancient crust. The entire planet is essentially naked to the flow of energy from the sun and beyond. As 3I Atlas travels through space, it is not a dormant rock. Its nucleus is actively venting gases, creating a vast envelope around it called the coma. Solar radiation ionizes these gases, stripping away electrons and creating a cloud of plasma. This plasma becomes trapped by the interplanetary magnetic field carried by the solar wind. As this ionized cocktail from an alien star encounters Mars, it does not simply bounce off. It interacts directly with the planet's upper atmosphere and its remnant crustal magnetic fields. The immediate and visible effect would be a dramatic enhancement of Martian auroras. On Earth, we see the beautiful northern and southern nights at the poles. On Mars, auroras would be a global chaotic light show, a planet-wide storm of dancing energy. But these spectacular displays are merely the visible symptom of a deeper disturbance. The real chaos would unfold in the ionosphere, a charged layer of the upper atmosphere. This region is crucial for reflecting radio waves, enabling communications with our orbiters. The influx of charged particles from 3I Atlas could severely disrupt the ionosphere's structure. The result would be prolonged radio blackouts, severing the digital lifelines to our robotic explorers. The Perseverance rover might find itself isolated, unable to receive commands or send its data home. The electromagnetic interference would not stop there. Mars is famous for its massive, global dust storms that can engulf the entire planet. Dust particles, when rubbed together in the dry Martian atmosphere, can become electrically charged. The passage of 3I Atlas could supercharge this process. Imagine dust storms where every particle carries a significant electrical charge. These storms could generate lightning displays that dwarf anything ever seen on Earth. Violent arcs of electrical energy could crisscross the sky, creating a persistent radio noise. This electromagnetic cacophony would further cripple communication efforts. It could also pose a direct threat to surface electronics, damaging sensitive instruments on our rovers. The scenario becomes genuinely alarming when we consider feedback loops. The charged particles trigger atmospheric changes that lift more dust. The dust, now electrically active, perpetuates the electromagnetic chaos. This cycle could theoretically become self-sustaining. Mars could be trapped in a quasi-permanent state of meteorological and electrical turmoil. The planet could transform from a quiet, dusty world into an electromagnetically hostile environment. Our spacecraft, designed for a predictable Mars, would be navigating a nightmare. Their star trackers would be confused by the shifting magnetic fields. Their solar panels could be degraded by charged dust abrasion. Their radios would struggle against a constant wall of static. This invisible assault, without a single impact, could achieve what a direct hit might not: the permanent isolation of Mars from easy human exploration. The concept of pansperium has long fascinated and haunted astrobiologists. It is the hypothesis that life, or its molecular building blocks, could be distributed between worlds. These biological seeds could hitchhike on comets and asteroids, spreading through the galaxy. When the delivery vehicle originates from another star system, the implications become profound. 3. Atlas presents a scenario that no planetary protection protocol ever fully anticipated. This object spent tens of thousands of years in the deep freeze of interstellar space. Its nucleus served as a perfect preservation chamber for complex molecules formed around an alien sun. The massive carbon dioxide emissions we observed were not just a curious anomaly. They were a potential delivery system for organic compounds that have never existed in our solar system. Data from the James Webb Space Telescope confirmed the presence of these exotic signatures. Buried in the infrared spectra were the absorption lines of complex, organic molecules. These were not the familiar amino acids or nucleobases we might hope to find. They were alien carbon structures, forged in the crucible of a star with a different chemical composition. Carbon dioxide, in the context of interstellar chemistry, is more than a simple gas. It can act as a solvent and a stabilizer, helping to preserve complex molecular structures across eons. The coma of 3I Atlas was not just venting gas, it was dispersing a chemical library from another world. The terrifying aspect of this contamination is its potential permanence. Unlike an electromagnetic storm that would eventually fade, chemical changes could be forever. Exotic organic molecules deposited on the Martian surface could integrate with the soil. They could alter the fundamental chemistry of the Martian regolith, the layer of dusty soil. These changes could create cascading effects that spread far from the initial deposition zones. The primary goal of Mars exploration has always been to answer one overarching question: did life ever exist here? Our most sophisticated instruments are designed to detect the subtlest chemical signatures of biology. What happens when those instruments encounter organic molecules from 3I Atlas? How could we possibly distinguish between a genuine sign of ancient Martian life and contamination from an interstellar visitor? Every soil sample, every atmospheric measurement would be thrown into doubt. The scientific implications could set back our understanding of Mars by decades. Future missions might accidentally study the chemistry of another star system instead of Mars itself. The contamination would not remain localized. Mars is a planet of global dust storms, weather systems that can engulf the entire world. Any alien organics deposited on the surface would not stay put. The next major dust storm would sweep them up, distributing them to every corner of the planet. Within weeks, the entire Martian surface could be lightly but pervasively contaminated. This has dire implications for future human missions and the concept of in situ resource utilization. Imagine trying to extract water from Martian ice deposits that have been laced with alien organics. Purification systems designed for known Martian chemistry might fail against these exotic molecules. Atmospheric processes intended to create oxygen from carbon dioxide could be fouled. The psychological impact on a human crew would be significant. Knowing the very ground and air contain chemistry from another star would be a constant, unsettling presence. International space law provides no guidance for this scenario. The Outer Space Treaty was written with human-caused contamination in mind. There is no legal framework for dealing with cosmic contamination from an interstellar object. The most disturbing possibility is that of a false positive in the search for life. The organic compounds from 3I Atlas could mimic characteristics of biological activity. A future experiment might signal the discovery of life, only for it to be a cruel mimicry. The Red Planet, our greatest hope for finding a second genesis of life, could have its biological story permanently obscured by a chemical phantom from the void. The gravitational dance between celestial bodies operates on mathematical principles that seem reassuringly simple. Objects attract each other with a force governed by their masses and the distances between them. This cosmic reliability, however, can mask a latent potential for chaos. Small influences, when applied to unstable systems, can cascade into enormous consequences. The Martian system, with its 2 small moons, exists in such a state of precarious balance. Phobos, the larger and inner moon, is already serving a cosmic death sentence. This irregularly shaped chunk of rock orbits incredibly close to Mars. It completes 3 full circuits around the planet every single Martian day. Phobos orbits so close that it lies well within what astronomers call the Roche limit. This is the critical distance where a planet's tidal gravitational forces overcome a moon's own gravity. In essence, Mars is slowly pulling Phobos apart. Under normal circumstances, this process would take another 50 million years to complete. Humanity would have ample time to establish itself on Mars and perhaps even find a solution. 3I Atlas introduces a variable that could dramatically accelerate this timeline. The direct gravitational pull of the comet on Phobos would be negligible at its flyby distance. The mathematics simply do not support a scenario where it directly yanks the moon from its orbit. But chaos theory operates in the realm of cumulative effects and cascade failures. Phobos is already a stressed world, showing deep groove minus-like fractures on its surface. These are likely the early signs of structural failure from tidal forces. Now, introduce the debris field of 3I Atlas into this delicate gravitational ballet. Even tiny particles, when traveling at interstellar velocities, carry tremendous kinetic energy. A grain of sand from the comet's coma, striking Phobos at dozens of kilometers per second, would hit with the force of a small bomb. Scale this up to thousands or millions of such particles, and you have a devastating sandblasting effect. This particular bombardment could provide the final push, stressing Phobos beyond its breaking point. Instead of a gradual disintegration over eons, the Moon could fragment catastrophically in a matter of hours. The result would not be the elegant rings of Saturn. Mars would find itself surrounded by a chaotic cloud of debris following wildly elliptical orbits. This debris field would range from house-sized boulders down to fine dust. The navigation challenges for any future Mars mission would become nightmarish. Mission planners would have to chart paths through a 3-dimensional minefield. Every maneuver would carry an unacceptably high risk of a catastrophic collision. This phenomenon, known as Kessler syndrome, represents a runaway chain reaction of impacts. Each collision creates more fragments, making the environment progressively more dangerous. On Earth, we fear this for our orbital space around our planet. For Mars, with its weaker gravity, such a cascade could render the space around it unusable for centuries. The psychological impact on humanity's Mars dreams would be profound. For generations, we have seen Mars as our backup planet, our cosmic lifeboat. To watch that future literally fragment before our eyes would be a devastating blow. The timeline for recovery could span geological ages, effectively closing the red planet to human exploration for longer than our species has existed. The orbital domino effect demonstrates that the greatest threats are not always the most immediate, but those that set in motion changes we are powerless to stop. In our modern age of digital connectivity, information can become a force more powerful than any impact. The most devastating consequence of the 3I Atlas encounter might unfold not in space, but here on Earth. It is the potential collapse of rational discourse in the face of cosmic uncertainty. Consider the perfect storm of conditions that October 3rd presented. The encounter occurred during a communications blackout, limiting our real-time data. The scientific analysis of any data would require weeks or months of careful study. The event involved an object whose behavior consistently defied our models. NAA, bound by scientific rigor, were measured in their public statements. They acknowledged the unusual nature of 3I Atlas, but avoided dramatic speculation. This cautious, responsible approach created an information vacuum. And nature, as the saying goes, abhors a vacuum. Social media algorithms, designed to maximize engagement rather than accuracy, rushed to fill the void. They naturally amplified the most dramatic and alarming interpretations of the incomplete data. Conspiracy theories flourished, suggesting cover-ups and hidden knowledge. By the time official scientific analyses were ready, public opinion might have been irreversibly shaped. Factual corrections would be dismissed as evidence of institutional deception. The precedent for this kind of astronomical misinformation is not encouraging. The delayed release schedule for definitive data compounds the problem. James Webb Space Telescope observations remained under analysis for months following peer-review protocols. This created a prolonged period where speculation operated without any factual constraints. Amateur astronomers, armed with impressive but limited equipment, shared their observations online. Their data, while valuable, could contain artifacts or misinterpretations. To a general public hungry for answers, these unofficial reports often seemed more compelling than the cautious silence of official agencies. Picture this nightmare timeline unfolding. 3. Atlas passes Mars with minimal immediate drama. Our orbiters implement precautionary protocols, temporarily reducing science data transmission. From a scientific perspective, this is a prudent safety measure. From a public information perspective, it looks like a blackout. Technical explanations about ionospheric effects sound like bureaucratic double-minus talk. Social media explodes with elaborate theories about what really happened. Computer-generated images of fake impact craters circulate faster than corrections can be issued. The psychological dynamics are clear. When people are primed for drama, scientific caution is interpreted as evasion. Congressional hearings intended to provide transparency could backfire. Representatives without scientific training might demand answers to unanswerable questions. This political pressure could force the premature disclosure of incomplete results. When those preliminary findings are later corrected, it feeds the narrative of incompetence or deceit. The international dimension adds another layer of complexity. Different space agencies, under different political pressures, might release information on conflicting schedules. These timing differences could be interpreted as evidence of coordination failures. The cumulative effect is a global information environment where multiple, contradictory versions of reality compete for public attention. The long-term consequences for space science could be severe. Public trust in space agencies, built over decades of success, could be eroded. Future missions might face skeptical audiences conditioned to doubt official explanations. The collaborative spirit essential for space exploration could be damaged. The 3I Atlas encounter served as a stress test for our civilization's information immune system. It revealed how quickly speculation can overwhelm evidence, and how fragile rational discourse can be in the face of the unknown. As we stand in the aftermath of the encounter, we must confront a deeper truth. 3I Atlas functioned not just as a celestial object, but as a cosmic mirror. It reflected back to us our civilization's deepest vulnerabilities and our need for growth. The encounter exposed critical fractures in our global information systems. We witnessed how quickly speculation can outpace evidence when phenomena challenge understanding. The same digital networks that enable global collaboration became vectors for misinformation. Our democratic institutions, designed for terrestrial politics, proved poorly adapted for cosmic uncertainties. International cooperation, already strained by earthly conflicts, faced new pressures. Different agencies providing information on different timelines created fodder for conspiracy theories. The collaborative spirit, essential for understanding the cosmos, remained vulnerable to terrestrial divisions. The amateur astronomy community, a source of valuable data, became fragmented. A divide emerged between those following rigorous protocols and those promoting exotic theories. The educational value of this real-time, cosmic mystery became complicated. How do teachers maintain scientific integrity when public discourse is dominated by sensationalism? Perhaps most revealing was the temporal mismatch between cosmic and human temescals. The universe operates on timelines that dwarf our political cycles and budget allocations. The most significant consequences of cosmic encounters may not appear for years or decades. This requires a patience and long-term commitment that our institutions struggle to maintain. The insurance industry's response was particularly illuminating. Underwriters, who price risk based on historical data, found themselves with no precedent. How do you insure a Mars mission when an interstellar object can alter the environment? Private space companies faced fundamental questions about the stability of their business models. The economic assumptions behind Mars colonization require complete reconsideration. The psychological impact on the space exploration community has been profound. Engineers and scientists who dedicated their careers to Mars are questioning their assumptions. The red planet, which seemed a predictable destination, was revealed as potentially far more dynamic. This revelation, while unsettling, might be 3I Atlas's most valuable gift. By exposing the fragility of our assumptions, it forces us to mature as a spacefaring species. We need more robust international frameworks for cosmic phenomena. Our current patchwork of agreements is inadequate for threats affecting multiple planets. Our detection systems need redesigning to account for the population of interstellar objects. The space between stars is not empty, it is populated with wanderers that can disrupt our plans. Technologically, we must rethink how we design systems for cosmic environments. Our spacecraft are engineered for the predictable conditions of our solar system. We may need to prioritize flexibility and resilience over optimization for known parameters. The lessons we learn from confronting our own ignorance are more valuable than any single data set. The 3I Atlas encounter was an unintentional stress test of our cosmic citizenship. The question is not whether Mars survived the encounter, but whether human civilization proves capable of learning from it. 3 months have passed since October 3rd, 2025. The world, with its short attention span, has largely moved on. Social media algorithms have pivoted to newer crises. Congressional committees have shifted focus to terrestrial matters. The initial dramatic anticipation has faded into a memory of an anticomus. But, in the data analysis centers of NASA, ISA, and universities worldwide, a different story is emerging. It is a story of anomalies so subtle they were initially dismissed as instrument error. It is a story of changes so gradual they required months of patient observation to confirm. Dr. Jennifer Walsh at MIT's Mars Atmospheric Laboratory noticed it first. While processing routine atmospheric data, she found molecular signatures that should not exist. Complex organic compounds with isotope ratios that defied every model of solar system formation. Their concentrations were infinitesimal, measured in parts per billion, but their presence was undeniable. These molecules exhibited characteristics never before observed. Carbon chains with unusual branching patterns, nitrogen compounds with alien isotopic signatures. Most disturbing of all, they displayed self-organizing structures that resisted normal chemical breakdown. Initial attempts to replicate these findings were met with skepticism. The signals were faint, the molecules were exotic. It took weeks of careful cross-validation before the scientific community began to accept the truth. The distribution pattern of these compounds revealed the scope of the event. The contamination was not localized, it was global, systematic, and pervasive. The same weather patterns that create Martian dust storms had efficiently distributed the alien chemistry. No future landing site would remain uncontaminated. The electromagnetic data told an equally concerning story. Mars's ionosphere exhibited persistent density variations unlike anything in the historical record. Communication windows with our orbiters became less predictable. The Mars Reconnaissance Orbiter's start records required more frequent recalibration. MAVN's particle detectors showed a gradual sensitivity drift. These were not catastrophic failures, but a slow, creeping degradation of performance. On the surface, the fine Martian dust began exhibiting different electrical properties. Dust devil encounters started producing electromagnetic interference that wasn't present before. The exotic chemistry was not just on the surface, it was altering the fundamental electromagnetic environment. Subsurface water ice deposits showed chemical alterations. The contamination had penetrated deep into the Martian hydrological system. The implications for future human missions are staggering. Water extraction systems might produce liquid laced with alien chemistry. Life support systems could be fouled by trace atmospheric organics. The timeline for understanding these effects stretches far beyond typical mission planning. We may not grasp the full implications until human explorers attempt to live in this altered environment. The red planet we thought we knew is gone. In its place is a world that wears a familiar face, but harbors a chemistry that could rewrite the rules of planetary science. 3I Atlas did not bring a dramatic catastrophe. It brought a quiet, persistent, and irreversible transformation. The unraveling truth is that the most significant changes in the cosmos are often the ones that happen silently, while no one is watching. As our story of Mars and its interstellar visitor comes to a close, let us return to a place of calm. The universe continues its slow, majestic dance, governed by laws of breathtaking elegance. The events we have explored remind us of both the dynamism and the resilience of the cosmos. Whether worlds are transformed by impact or by subtle chemistry, equilibrium is always found. The silence of space is not an emptiness, but a repository of infinite possibilities. Let the vast, peaceful scale of it all wash over you now. Release the tension of cosmic threats and scientific uncertainties. Feel the weightlessness of simply being an observer in this grand, beautiful universe. The mysteries of alien molecules and transformed planets can fade from your conscious mind. Bring your awareness back to your breath, to the quiet rhythm of your own body. The stars will continue their journeys, the planets their orbits, with or without our watchful eyes. For now, let it all go. Allow the deep, enveloping quiet of the cosmos to be your blanket. There is no problem to solve, no mystery to unravel, only rest. Drift among the quiet stars and surrender to a deep, peaceful, and restorative sleep.